Hi there, my name is Simon Dennis, and I'm going to give you a tutorial about how SSL works. SSL is something that's given me a lot of trouble over the years, and I know it's quite difficult to wrap your head around how the whole thing fits together. So this presentation is going to aim to do just that. What we're going to cover today? Well, we're going to cover why SSL and certificates exist. Broadly, there are two reasons why SSL and certificates exist. That's encryption and identification. So I'm going to go into encryption, finding out why we encrypt things, what good it does, and how that encryption actually works on your computer and on the web server. And then I'm going to go into identification, and that's how your web browser can trust what computer is on the other end. Okay. Okay, now like I said, there's two facets to why SSL exists. That's encryption and identification. Now encryption is basically hiding what's sent from one computer to another by changing the content. So it's like speaking in a code. I don't know whether you remember Pig Latin or Morse code. Well, these are all examples of code, but the code we use to encrypt our communication between two computers is obviously a lot more complex than that because we don't want it to be cracked easily. There's also identification. Now, how can you trust what computer is on the other end? How can you trust the computer on the other end is the computer you think it is? We'll go into both of these. First, we're going to cover encryption. Okay, now, typically, if you're going to send your credit card details to a server over the web, here we can see your computer on the left, the server on the right. We want to send the credit card details, so they go across. Now, without SSL, this information can be grabbed by another computer we see here on the bottom. So if you don't use SSL, any computer on any of the networks between you and the web server can get your details that you send over. So SSL aims to put a barrier around that so that when this other computer looks at it, it will just see garbage. Okay, so let's take an example. Google's Gmail service will encrypt using SSL the username and password you send it to. Now, how do we know this? If you look at the HTML behind the page, you see that when it submits the login details, the action in the HTML code begins with HTTPS. So that's indicating that it wants to submit the form securely. Now, once you press submit, there's several steps before the actual encrypted data is sent. This is called the handshake. Number one, the computers agree on how to encrypt the data between them. Number two, the server sends a certificate containing details about itself and a key to encrypt the data. Number three, your computer says start encrypting. 4, the server says start encrypting. Now all messages are encrypted. So what I'm going to do is I'm going to take you through each one of these 5 steps, explaining in detail how that works. Now the first part of the SSL handshake has the computers agreeing on how to encrypt with each other. First, the client computer on the left here sends a hello message to the server, here shown on the right. The information in that hello message contains the key exchange method, here that's in the first column where I've shown RSA, Diffie-Hellman and DSA. Second is the cipher, that's the way of encrypting the data between the two servers. And then third is the hash, and that's used to generate something called a message authentication code, which is sent along with these different messages, and so they can ensure the integrity of them. The key exchange method, for more information, if you look up transport layer security or public key encryption on Wikipedia, you should have more information about that. It's kind of beyond the scope of this slide. Also sent is the version of SSL, in this case 3.3, indicating TLS, and the random number, which is used to compute the master secret, which is then used from then on to calculate the encryption keys. Now once the client sends that message to the server then sends a hello message back to the client saying, I choose this key, this cipher, and this hash method. So now they've agreed, the client has said, this is what I can do, the server said, right, I pick these, and now they're ready to go on to the next stage. Now the next stage, the server sends a certificate to the client. Now the certificate contains information about who the server belongs to, how long the certificate is valid for, various serial numbers, and more importantly the public key. Now for more information about public key encryption, like I said, go to Wikipedia, they've got a great bit of information about that. So the server sends a certificate to the client. Now the next step is your computer says let's start encrypting to the server. There's actually 3 messages that accomplish this. First is the client key exchange. Now once this message is sent, both computers can calculate a master secret code, and from then on that master secret code is used to encrypt all the communications from then on. Your computer then says let's change to the cipher spec. Now that cipher spec will be the one that was previously agreed in the hello messages. And then your computer says, right, I'm finished. So it's saying let's start now. The next step is then the server says, right, let's start encrypting. So it gives the cipher spec, and then it says I'm finished. Let's go. Now the only thing is, when this message gets sent to the client, it gets encrypted. So the finished message after the cipher spec is then encrypted completely, and it gets sent back to your computer. Now all messages are encrypted, so in our Google example, perhaps our login is Jane Doe and our password could be something like this. Now when it's encrypted, this will be garbage to anyone watching, and that's how encryption works. Now the other reason SSL exists is identification. That's making sure the computer you're speaking to is the one you trust. Because you can have an SSL certificate, but that doesn't mean necessarily that the computer that you're talking to is the one you think it is. It just means that communication between it and you will be secure, which isn't enough. So let's look a bit more into this. Now when you're about to send some information to people over SSL, usually there's a way of finding out who that information is going to go to. Usually you double click the padlock and a window will come up telling you. Now behind that there's a whole load of infrastructure. Firstly, there's a process that the organization you're going to send your data to has to go through. They have to communicate with another organization called a certificate authority. So an example of that would be VeriSign. Now the organization has to ask the certification authority for a certificate. The certification authority will then look up the details of that company, verify that it's true, create a certificate, and cryptographically sign it in a way that cannot be forged. Then they send the certificate back to the company, who then installs it in their web server. Now you, on the other hand, have a web browser and you want to view the information on that certificate. Your browser will only tell you if there's a problem, but it can tell there's a problem because it's got a whole lot of certificates which in a way can vouch for the certificate you get from the organization. Are you holding on? Your browser will trust correctly signed certificates, but it will not trust incorrectly signed certificates, or certificates that have come from a different certification authority that is not trusted. But we'll go into each step of this, so don't worry, hold on. Now, first, the company asks the certification authority for a certificate. In order to do this, the company has to give a whole lot of information about the web server that they're running it on, what the company is, where it's located. Now the certification authority checks the correctness of this information and the authenticity of the company by going through public records, receiving letter-headed paper, and generally just checking up. A bit like an application for a passport. Now the next step is the certification authority creates the certificate and signs it. So here we've got a certificate. And this is the information you typically find. You've got the version, the serial number of the certificate, the algorithm ID, the issuer, when the certificate is valid, so 2 dates, the details of the company called the subject that's applying for the certificate, the public key information that includes the algorithm and the actual key, issuer and company identifications possibly, and then a signature algorithm and a signature. Now the signature itself is created by condensing all the details in the certificate, apart from obviously the signature algorithm and the signature, into a number through a hash function. You can find out more information about hash functions by looking up, say, Wikipedia on MD5, which is a hash function. So all the information on the right will be condensed into one number, and then the certification authority encrypts that number with the private key. So anyone holding the public key can verify it's correct. There's the signature. Now that certificate is then given back to the company who installs it in the server. So the company will run a web server and that certificate is installed into it. They may run Apache or Tomcat or WebSphere or WebLogic. most likely Apache, who knows. This certificate is installed in, and you can configure the web server to then use the certificate. From then on, that certificate is going to be used in the handshake process we outlined. Now let's go to the other side, where you, on your browser, are trying to get information from a site through SSL. Now, how does your browser know whether to alert you or not? Well, the answer is it's shipped out of the box with certificates from certification authorities all around the world, and that enables it to check the authenticity of any certificates it gets. Now, each one of the certificates that your browser is shipped with has the public key of that certification authority in it. So when it receives a certificate from the site, it's able to verify that the signature at the bottom is absolutely correct. Now that concludes this tutorial. If you have any feedback, I'd love it, whether it's positive or negative. You can either catch me on sdennis@leadingcoder.com, or you can leave comments on the blog. That would be fantastic. Thank you very much.